それではお時間となりましたので、始めさせていただきます。これからの時間はですね、T. アレクザンダー様による、メジャーリングソフトウェアデリバリーオペレーショナルパフォーマンスの講演となります。ただですね、今回は、ちょっと時差の都合上、アレクサンダーさん、ビデオでの、録画での、登壇となります。なので、このままですね、ビデオを設定して再生させていただきますので、終わった後の質疑応答申し訳ございませんが、ございません。もうしばらくして準備ができましたら、ビデオの方流させていただきます。
Hello, I'm Alex and I work in Visma as the Director of Cloud and Engineering. And today I'm going to talk about why we started to measure software delivery and operational performance, how we do it in practice, and a little bit of our initial analysis of those metrics. So first, you need to know a little bit about the Visma context, just in case you don't already. Otherwise, what I'm going to show you will not make as much sense. You also need to know this to understand whether what we are doing will work in your context or not. So in Visma, we make lots of different types of cloud software, and we're a company of many cloud software companies. Visma consists of more than 200 companies, and our software companies have a lot of autonomy on certain financial things and security things. We standardize, and there are some mandatory things that all Visma software companies have to do. But in terms of technology choices or methodology choices, companies are free to choose what makes sense for their business, and then we support them centrally if and when they would like to be supported. We have a lot of products across many countries, so it's a very heterogeneous environment to work with, which is very exciting and interesting, never a boring day at work, but it also gives us some unique challenges. In Visma, since 2015, we have had something called the Visma Cloud Delivery Model, and you can understand more about what this is if you watch my previous tech talk on how we work with DevOps in Visma. But this is something that we have been developing and rolling out in Visma over many, many years. And we have about 80 teams working according to the Visma Cloud Delivery Model today. It is Visma's recommended way of developing, delivering, and operating cloud software. But teams and companies are free to choose whether they would like to follow this model or not. There is a team that helps any team or company onboard to and follow this model. And it has been used as a kind of a transformation program in Visma for many years, to move away from the old way of working to the new way of working. So instead of having siloed teams where development and operations are separate from each other, we know that leads to a lot of problems. Instead, when teams and companies are working according to this model, the Visma Cloud Delivery Model, developers and development competence and operations competence are in the same team. So we focus a lot on cross-functional autonomous teams that have end-to-end responsibility. Similarly, to move away from deploying software once a month to doing that on a daily basis, and moving away from relying on traditional infrastructure that's based on virtual machines that are maybe provisioned manually, not a lot of automation, to using public cloud platforms with all the benefits that entails, but especially in the automation area, being able to use container technology and serverless technology more easily. That's also part of this transformation program. So as I said, we started this, developing it and rolling it out in 2015, and today we have about 80 teams in Visma working this way, and we're still modernizing the model, improving it based on our own experience and other developments. So we will cross 100 in a year, I think. But then, while we were doing this, in 2018, this book came out that I think many of you will be familiar with, the Accelerate book. For those who are not familiar, this book is a summary of research that was done based on global survey data that was gathered over 5-6 years. And in these surveys, people were asked to, about how they develop, deliver, and operate software in their organizations. And they were asked how well their organization was performing. And the goal of these researchers was to try to identify what kind of practices and behavior and metrics actually lead to high organizational performance. And in their research, they were able to identify 4 to 5 metrics that strongly predict, or that most strongly predicted, the performance of an organization. And they called this construct of metrics software delivery and operational performance. And they found that the organization that had the highest software delivery and operational performance were twice as likely as the other organizations to meet or exceed their organizational goals, which for private companies often are commercial goals around market share, number of customers, profitability, revenue, etc. So of course, this was both interesting and very good news for us in Visma, especially we who were working with the Visma Cloud Delivery model, because on the one hand, we felt that a lot of the things that we were talking about, continuous delivery, DevOps, public cloud, they were all mentioned as factors in this research leading to higher commercial performance, higher organizational performance. And we were also then able to use this research in our internal communication to further drive awareness and understanding about what we were doing with the Visma Cloud Delivery model. Then in 2020, something similar happened. McKinsey released their report on Developer Velocity Index, where they looked at hundreds of companies over several years as well. And they identified their construct called Developer Velocity Index, which consists of something like 46 metrics that are all about how the organization works with software or product development. And what they found was that the companies with a high Developer Velocity Index grew faster than those with a lower Developer Velocity Index. In fact, as you see in this diagram, the top quartile, the top 25% of companies in terms of Developer Velocity Index, grew their revenue 5 times faster than the bottom 50%. So quite significant findings, and of course very interesting for any company, and especially interesting for us in Visma with the Visma Cloud Delivery model, and also considering the research from Accelerate. It seems like we're all telling the same story, that engineering performance drives commercial performance. And that's something that we can use and build upon, right? So then we were asking, well, how do we measure engineering performance? And in the Accelerate book and the State of DevOps report, which the book is based on in large part, they already had this concept of software delivery and operational performance. And we measured some of this already, and these are all of these 5 metrics are metrics that we care about anyway, even before the book came out. So we thought, well, let's make sure that we have this data and these metrics so that we can see what they say, what we can get out of them in Visma. So now what I'm going to do is to go through metric by metric and talk about how we have defined them and how we measure them, because if you try to do this yourselves, you might see that there are some gray areas. So I'll try to explain how we have resolved those gray areas in Visma. So the first metric is delivery lead time. And you might know that in the Accelerate book and the State of DevOps reports, this metric is usually referred to as lead time for changes. But in Visma, we consistently talk about this as delivery lead time. And the reason is, and maybe you have found this already, or you will, that people have very different ideas about what lead time means. So we put delivery in front to make it clear and to remind everyone that in this case, we're talking about the time it takes to deliver a change to production. So it does not include design time, it does not include implementation time, it's only about the delivery process. So to calculate this, if you know when a change was deployed successfully to production, and you know when the implementation phase ended, then you just take the difference, and that's your delivery lead time for that change. As I see it, the most important thing about this metric, the most valuable thing, is that you can use it to identify bottlenecks in the delivery process. So if you're spending a lot of time on manual testing, for instance, or you have other speed bumps, then that will be identified in this metric. However, you can ask some questions. Should all kinds of testing be included in the delivery lead time? And I think when you have questions like this, go back to the purpose of the metric and you will most likely find your answer. So if we're talking about implementing automated tests, I think that's clearly part of the implementation of the change, so that should not be counted as within the delivery lead time. But if you're talking about executing either automated or manual tests as part of the delivery process, so you have your build process and you're running automated tests on your build or CI server, then that would be included. If you're deploying your product, your system to a staging environment or an acceptance environment, and you're doing manual testing there before you're confident enough to deploy to production, then obviously that is included as well. What about code review? I think this is a bit of a gray area. I think you can argue it both ways. But if, let's say you have a team where developers are asking for code reviews in order to get their pull requests approved and merged into a main branch. Now, if that team has a culture, or if it's tooling or any issues that are causing developers to not to jump on code reviews soon enough, but maybe requests for code reviews are laying around on the shelf for many days, then clearly this is slowing down your delivery process, because in essence, the change is more or less done, but you are waiting. So ideally, I would include code review, although you can argue it both ways, I think. Deployment frequency, this metric is probably the simplest one, right? We just count the number of deployments to production, and this gives us some idea about the throughput in the organization that we're measuring this for, let's say in a team or in a company. But more importantly, we are getting some idea of the cost of change. And we'll get back to that in a second. Then we get to change failure rate. And this is slightly more complicated. In the book and in the State of DevOps reports, this is defined as the percentage of deployments that causes a failure in production. And we care about this because when there are failures, usually there is double work, right? We're doing work that was unnecessary. And often there can also be an impact to users in the quality of service that we're providing to customers. So it's a good thing to measure, and it can tell you whether you are ready or not to increase your deployment frequency, for instance. If you have a change failure rate of 15, well then probably you need to iron out those issues and not speeding up your delivery. But if your change failure rate is close to 0, that's a good sign that you're ready to increase your delivery speed, your deployment frequency, etc. There are some problems with this definition though, because it implies that you should causally link failures in production to individual deployments. But let's imagine that you are deploying something to production and you have a failure that doesn't manifest until a day or 3 days later. Then you need to figure out, okay, which deployment caused this failure, and you need to keep track of that. That seems a little bit impractical to me. So in Visma we use a good approximation for the change failure rate. We say, well, the rate at which the system fails when we change it, that is the change failure rate. So we just need to know the number of failures, and we need to know how many times have we tried to change the system. When we divide those numbers, we get the change failure rate. So in order to get the number of failures, we take the number of failed deployments. That's the failed automated changes. And we take the number of incidents, any type of incident where there has been significant customer impact. And we add those numbers together, and that's the number of failures that we have experienced with the system. Then we divide that by the amount of deployments that we have had. That's all the automated changes we have tried to apply. And we take the number of manual changes, because once in a while, doesn't happen very often, but once in a while a team will make a change to the system, not in an automated fashion, not through the delivery pipeline, not through a deployment. And then we count them as well as times we have tried to change the system. So that's how we approximate the change failure rate, and it seems to work well. Then we have the time to restore metric. This is the time it takes to recover from unavailability, and we'll get to how we define that in a second. But how ready we are, right? This is a measurement of how prepared we are for failures. If we are prepared, you expect to see a lower time to restore on average, and you can use it to identify also any bottlenecks in the recovery process itself. So also a fairly simple but very valuable metric. Then we have availability. And there are different ways of doing this. We look at the percentage of time the system was available. And we calculate that by taking the time of the reporting period that we're looking at, whether it's a day or a month, let's say, and we subtract the time the system was unavailable. Multiply that by 100 and you have an availability percentage. The value, I think, is obvious, right? It's a measurement of the operational quality, also in a way how reliable service are we able to deliver. And it's one important measurement to also let us know how the quality that we're delivering to customers. The question though is, how do we determine whether a system is available or unavailable? It's kind of a binary metric when we do it like this. What we say is that a system is unavailable if there has been significant negative customer impact for any reason. And this will vary depending on the context, which from our perspective is a good thing, right? So we're kind of giving this decision to the teams and the organizations. They need to decide whether the system was unavailable enough, let's say, in their context. Was the negative customer impact severe enough? So let's say my system is an online bank, and the profile picture doesn't load. If I'm talking to my financial advisor and I don't see the profile picture, that's not significant enough to count my online bank as unavailable. But if we were talking about a social network where profile pictures don't load, it might be a different story, right? That's a much bigger part of the functionality, a much bigger part of the value to the users of a system like that. So in that case, we might count it as unavailable. If 20% of users are not able to log in, well, that's clearly a significant negative customer impact. So at least in most contexts. Now, how do we get teams to report these metrics? We ask our teams to report this through Jira. Jira is one of the tools that are most widely adopted across the Visma companies. And teams will submit the data we need either automatically through the API or manually through the web interface of Jira. Then we replicate that to another database, which is where we run our reporting. And currently we're running our reporting in Tableau, which I'll also show you in a second. So what are we asking our teams to submit into Jira? Well, the first thing is that for every deployment to production, teams submit a Jira issue about that deployment. So here you see they identify what product or service or component that they're reporting data for. They say whether the deployment was a success or a failure. They include how many changes was part of that single deployment, and they calculate the total delivery lead time for all the changes in that deployment. And how do teams do this? Well, they add a script to their deployment pipeline. Then, once in a while, if a team needs to do a manual change to their system, they will manually create an SDOP change issue in Jira, whether it was a success or a failure. And if there was any unavailability, meaning significant negative customer impact, they will also add the start time and the end time for that unavailability. And finally, as you might expect, teams are reporting high impact incidents in Jira as well. So if there for any reason is significant negative customer impact, then they will register when that started in time and when that ended in time. So as you might expect, this is then how these different issue types in Jira will inform the metrics that we calculate. You can see that for the change failure rate, for instance, we use information from all the three issue types. Then I thought I would show you an example of some of our reporting. This is the report that focuses on deployment frequency. So these reports are open to any employee in Visma. It's very transparent in that way. Any team member or team manager can look at the performance of their team if they are so inclined, to track their performance over time if they want to. And they can also benchmark themselves against other teams or companies in Visma. And this is what it looks like, the report for time to restore as an example. And we have this for all the 5 metrics. Some teams even created their own reporting connecting directly to the data source, which is very nice because then they can get the exact reports that they want, and we get some ideas for how to improve the centralized reports that we offer out of the box. Now in Visma we have a lot of data across our companies, and the software delivery and operational performance is only one part of that, right? We also know things about how happy our employees are, how happy our users of the different products are. We have financial data. We know a lot about how our different teams are working. So we have started a project where we are trying to gather this data as much as possible, identify new data that we might want to use in our analysis, and then performing analysis on the combination of all of this data to try to gain some insight. And of course, one of the things that we are asking is, can we say something about what kind of practices lead to better products, happier employees, happier customers, and better commercial growth? So what happens if we combine the software delivery and operational performance data with the finance data, for instance? We have measured deployment frequency in Visma for a longer period of time. So we have pretty good data on that centrally in Visma. For the other software delivery and operational performance metrics, we started measuring those in a structured way centrally fairly recently. So the analysis that I'm going to show you is focused on the deployment frequency. And what we see is that the top 25% of Visma products, in terms of deployment frequency, grow more than 4 times faster than the bottom 25%, which is quite significant. Roughly speaking, we can say that the top 25%, those are the products that are deploying to production on a daily basis, while the bottom 25%, those are the products that are deployed to production on a monthly basis. And if you think this graph looks a little bit familiar, it's because it is very similar to the one from the McKinsey report, where they looked at 46 metrics, right? They found a 5x increase in the revenue growth rate for the top 25% compared to the bottom 50%. So, and remember, they looked at 46 metrics. In our analysis, we only looked at deployment frequency, but we see the same pattern. And I think you have a right to ask, why would such a technical and superficial metric, at least seemingly, be able to capture anything that is true about the commercial performance of an organization? That doesn't make any sense, does it? Well, I think it does, and I think there are at least 3 reasons. The first one is that a high deployment frequency is an innovation capability. If you're able to make adjustments and learn from it, get feedback on that, and you do that hundreds of times during a year, you're much more likely to reach a better, build better products and build better products in a less wasteful way than if you are adjusting and learning only 12 times a year. So it's an innovation capability. The other thing is that if you have a high deployment frequency, then each change you make is smaller, which will have a positive impact on the quality and reliability of the product. But most importantly, if you want to sustain a high deployment frequency, it has to be easy and cheap and as frictionless as possible to make changes and improvements to the product. And that is what I think is capturing so much about an organization. Because let's think about what can have an impact on this. What can slow you down in your deployment frequency? Well, if you're deploying on a schedule, if you have a release day every first Tuesday of the month or every Monday or something like that, it's a little bit of an older way of working, a bit waterfall-y. It's going to hold you back in terms of deployment frequency. You want to be in a place where you are comfortable deploying changes to production when they are done and not wait for some deadline. Then if you have maintenance windows, because when you deploy there is downtime for customers, that's also something that's going to hold you back. If you're spending time on manual testing and manual deployment processes, that's going to have an impact on your deployment frequency. If you need to spend time working around old technology, if your organization doesn't really scale, if you're lacking key competence, or if you have a poor culture, all of these things are going to impact your deployment frequency. And I think that's what explains the impact of the metric, why it's able to predict and say a lot about the commercial performance of an organization. Another thing that we noticed is that for the Visma products that we don't have the deployment frequency data, those are the products that grow the least. So naturally we are using this as an incentive to teams and companies within Visma to start measuring, to start caring about this, and to work on improving it. Of course, there can be many reasons why a product is not measuring deployment frequency today. The fact that some products are old or in maintenance mode, of course, plays a part here as well. But we see this relationship with many other metrics too, where we are not collecting an important metric, those are often the products that are performing the worst. So I guess it's true what they say, that in order to improve something, it helps a lot to measure it. You need to know where you are. The final result I'll share with you is about public cloud. Public cloud is not mentioned specifically as part of the software delivery and operational performance metrics, but in the Accelerate book and in the State of DevOps reports, the research talks a lot about how the 5 NIST cloud characteristics help you improve your software delivery and operational performance. And that is the same thing that we have found in Visma with public cloud technology as well, that it helps us modernize our products faster, and it helps us modernize how we work faster. So here we have compared the innovation rating for our products across different hosting technologies. And we see that the products that we have in public cloud are more innovative. Similarly, we see that the products that we have that are hosted in public cloud are much better liked by the users of those products when we compare public cloud to traditional data centers and even products that are running on premises at a customer site. So this is pretty interesting, but also not super surprising. So what we are doing now moving forward. Today I've talked mostly about software delivery and operational performance, and that's one part of engineering performance, which is a little bit of a broader term, where we're also interested in looking at things like security and technical debt and other things. We're also doing research when it comes to the user engagement and advocacy, employee engagement, innovation, and customer centricity. And we think that all of these 4 areas are really important for commercial success. So moving forward now, we've got this project up and running. We're starting to do analysis of all of our data sets, not only software delivery and operational performance. So hopefully I will be able to share more results with you in the future. Thank you for your attention.